All right. Good morning, year sevens. How are you today? Let me know in the chat below. Welcome to another session of Mathspace Academy for year seven. Today we're doing rates and ratios, and there's not many of us today, but hopefully we're still going to have some fun. I'm going to ask Yasmin to join me on the call right now, and we'll just have a bit of a chat while we wait for more people to rock up. Good morning, Yasmin.
Good morning. How are you?
I am excellent. How's your week been? Been good?
Good. Yeah, finished my uni exams last week, so now I'm relaxing at work, doing some work, working hard. What about you?
Just with the whole lockdown thing, just staying at home. And let's be honest, I love staying at home.
Yeah, me too. I love it.
Yeah. How's everyone else doing with the whole COVID situation? Are you enjoying being at home? And actually, you're all going back to school now, aren't you?
Yeah. Is everyone back at school?
Now, yes, we've got a couple of questions today, just to kind of get to know each other. And if you guys at home can answer these questions too, please feel free to do so. My first question for you today is, did you fail anything at school?
Yes, I failed a couple of things at school. In year 7, I failed, I think we had to do software or something. I failed miserably. I remember it was a test. It was open book too, I think, and I still failed. It was just not my thing. And then I also failed when I moved schools in year 9. I moved mid-year, and they had done, the school that I moved to was doing this science course that I had done in like the complete opposite order. So I failed one of my exams because I hadn't done any of the things, and I showed up right in the middle of it. So yeah, I failed a couple of things, but
yeah. More importantly, right, like everyone fails at some point.
Yeah.
What did you learn from it?
I think, well, failing in year 9 was a really good thing for me. I ended up going into a class because a different class because I had failed, which actually had a really great teacher who ignited my passion for science. So ended up being a really good thing, and I learned from it, learned to work hard, not just sort of like think, oh, okay, it's fine, it's whatever, I'll just pass, you know?
Yeah.
Have you ever failed anything?
Yeah, absolutely. Oh, so many things. No, I lie. I probably failed, but the one thing that sticks out of my mind is when I was in year 12, so the final year of school, and there was like a spot test for a topic that I just hadn't covered. Like obviously the teacher had done it in class, and a week had gone by, and they gave us a spot test, and I just had no idea what I was doing. And it was like maybe a small test out of 10, and I got 0. Like I literally did not know how to do anything. Yeah, that wasn't good. That was a big wake up call, and kind of got my butt into gear. I was just like, oh my goodness, I need to start doing some work. And yeah, so ever since then, it's been really good because sometimes you need those shakeups to kind of for you to reevaluate what you're doing with yourself and hopefully do better.
I agree. I think failing for me has always turned into a positive experience. So not too big of a deal, not as big of a deal as everyone sort of can make it out to be too. But I have a question for you.
All right, sure. What's your question?
Okay, so we have lots of little year 7 kiddies here today. And I was wondering, when you were in year 7, if you could go back and talk to your year 7 self, would there be anything that you would want to say?
Oh, what would I want to say to myself? I would say to myself, do more stuff. And when I say do more stuff, like as a kid, I did nothing. I watched TV. I watched so much Pokemon and Dragon Ball Z. I don't know if anyone knows what these things are.
I love Dragon Ball Z. I used to watch Dragon Ball Z too.
And I used to play a lot of computer games. And so I think I would go back and tell myself, do something that builds skills. Like I don't mind me doing all that stuff now, like especially because now I can talk to other people about it. Like it's not completely useless, but I would have said like, maybe do some things that that I might use later on. So things like maybe playing an instrument, even just for fun, like not do it hardcore, or learning how to program, or something's a little bit more useful. Not saying that, but it was definitely fun. What about you? What would you tell yourself?
I think I would tell myself to participate more within like I suppose mainly like with the school community and stuff, I was very much like, oh, I don't want to do that. Like SRC, there was an environmental club and stuff like that, and I wish I got more involved so that I think it would make my school experience more more valuable in a way. It was still really good, but it'd be nice to also contribute.
What's SRC?
Student Representative Council.
Okay.
Yep.
Cool. That's really good advice. I think both of our things that we'd say to each other are actually quite similar in a way.
Yeah, I think so. They're almost the same. When you said it, I was like, oh, that's my answer to my own question. But we have some Dragon Ball Z fans in the chat.
Oh, really?
Super Saiyan.
All right. Well, we might get started now. Hopefully, we've got a few more people in. And let's make a start. Thanks for having the chat, Yaz.
Thank you.
All right. Have a good day. Now, just remember that Yasmin's here to help us out and just keep everyone on track. So please make sure that if you are using the chat, don't go off on random tangents. Don't spam. Just use it responsibly, please. Otherwise, Yasmin will have to turn it off. Okay, let's make a start. So, just like every other time, we are going to play a game at the end. So just make sure you've got another device or split your screen up into 2 different windows, but we'll do that later anyway. Definitely have a piece of paper in front of you today so that you can do some working out. Now, we're on to rates and ratios. Can I please have a show of hands? Hands up if you've done rates and ratios already in school. I just want to know so that I know how much I need to actually teach compared to just kind of assuming you know this. Because all the percentage decimals fraction stuff, I assume that your school's done it before. So 2 people have done it already. Just put up your hand. If you go into the chat, I think. I can't remember where you can put up your hand. There's somewhere you can do it. You've never done it. Okay. So I might go a bit slower with this one. I might do a bit more teaching. So for those of you who have done it, just bear with us and feel free to jump in and answer the questions when we ask them. All right. So today, well, we've already done it. We've already done Meet Math Master Yasmin. We're going to go through last week's question. I don't know if anyone's already, did last week's puzzle question. I didn't get sent anything through to me. It was actually quite a decent chunk project if you wanted to attempt it. We'll go there in a second. Then we're going to do some Math for Life again, somewhere where maths will actually help you out. And this time it's in the supermarket. Then we're going to do some rates and ratios in Mathspace, play a game. Unfortunately, I tried to run the game yesterday, and all the cool game modes that we had last week are gone. So like, oh, that wasn't cool. We'll just have to play a normal one for now, but we'll see how we go. And then I've got a puzzle at the end as well. Now, on to last week's question. My question was, which country is the most athletic country? Now, I'm just going to check the chat here. Did anyone actually have an answer to this? No? Okay. Oh, Sinan did? Let's have a look. Someone asked, how many lessons do we still have? I think we're about halfway through. So we'll go to the end of term 2, I believe. Okay, so what we went on with is I said, well, look, here's some information. There was the 2016 Rio Olympics medal tally, and I based all of my information based off this. Now, lots of people just Googled it, and it said, it's Russia. I beg to differ, right? Not just because Google said, but I went through and I did some maths, and I created another spreadsheet. Last week, I showed you guys a spreadsheet, and you're like, whoa, mind blown, what's going on? Again, if you ever get the chance, or if you ever feel interested, get into learning how to use spreadsheets. I guarantee you use it even when you're an adult. I use it all the time. It's actually quite easy math. You learn way harder maths in high school and in uni, and then as an adult, you just use basic math in a spreadsheet form, really. So this is what I did. I took all the data for about gold, silver, and bronze in 2016. Unfortunately, we don't have the Olympics this year. And then I went and found the population of each of the countries. Now, I didn't do the populations for all the countries. I stopped it at the top 50. After that, I was like, there's so few medals there, I can't be bothered doing all of them. And then I actually determined how these countries went in the Olympics compared to their population, right? So sure, US got 120 medals, but they had 323.9 million people. Whereas look at this one here, Great Britain, 67. Yeah, sure, they got half the amount of medals, but they've got 65.6 million people. That's way less than half the population. So proportionally, Great Britain surely is more athletic than the US, right? Now, what I did was I then did 3 measures, right? I did 3 different things to see how they would compare. I figured out how many medals did each country win per million people. So if I took the total here, 121, and I divide it by 323.9, that's how many medals they would get per million people. I did the same thing, but I did just gold medals, right? How many gold medals would the US have won per million? And then I actually did something a little bit different again, which was if I took all of those medals and I gave them a score, right? So I said, if a gold medal gave you 3 points, a silver medal gave you 2 points, and a bronze medal gave you 1 point, and I took all those points and I divided by how many people lived there, that's the points per million, right? So these were my 3 different measures for deciding how athletic an entire country is, an entire nation is, right? And of course, Russia is going to say they're the most athletic, right? I don't know who came up with that information, but I assume it's the Russians. Then, after I did all of these maths, right, of finding all of these measures, and by the way, these are all rates, right, which is what we're going to talk about today. Rates of medals per million, gold medals per million, points per million, right? I went through and I ranked them all. So I went through and I said, okay, the spreadsheet did this for me. I said, tell me, out of this medals per million, golds per million, the points per million list, what rank did they come out of the 50 countries which I did this for? And what was really interesting is I came up with these graphs and I came up with this information. So I'm just going to jump out of the spreadsheet now and I'll show you what I came up with. This is the medals per million graph. So the higher it is, it means the more medals they got per million in their country, per million people in their country. So you can see here, this is the tallest one. This is Jamaica. Jamaica crushed most other countries, right? They had over 4 medals per million people. Then the next after that was New Zealand. I was very surprised by New Zealand. And then after that was Denmark. And then after that was, I think this is Croatia, right? So for the medals per million, I got this information. Then I did the same for the gold medals per million. You can see here, again, Jamaica is just crushing the rest of the world. Jamaica, Croatia, so Croatia popped up again. Then the next one after that was, I think, again, New Zealand. And then after that, Hungary. So far, we can kind of see who's the leader here. And then points per million, Jamaica. So all 3 of the things that I measured, Jamaica crushed everyone. So that's who I'm going to say is the most athletic country in the world. Now, if you don't agree with me, totally am happy for you to disagree with me. I want you to go back, do some maths, and tell me why I'm wrong, right? That's the whole point of maths and science. You're allowed to disagree. You just got to prove it. So please, feel free to prove me wrong. Now, let's keep going. We're going to now jump into rates and ratios, and we're going to be talking about how do you choose which ice cream to buy when you go to the shops, and where do you go to buy it? Now, last week, I asked Yasmin about what her favorite food was. I forgot. Oh, well, I didn't forget. I'd said that my most favorite food is potato because I just love potato. The second most favorite food that I eat, definitely ice cream. I have it probably almost every day, if not every second day.
I do love ice cream too.
Yeah. Just put your hands up if you love ice cream, please. Represent. Now, can someone please on the chat tell me, how do you choose which ice cream to buy? I don't know if you, probably your parents probably go and buy your ice cream for you, let's be honest. But if you had to go to the shop, what things would you think about? What information would you consider for what you would buy? In the chat, go tell me, what are the important factors for you? Someone said price. Definitely. I am definitely concerned about price. Who buys those tiny little tubs of ice cream that cost like $1 bajillion? Not me. Anything else besides price? Quality? Definitely. I cannot, well, no, I can't, not that I can't, but I am a bit of an ice cream snob. I don't really like black and gold ice cream. I'm sorry, guys. Black and gold ice cream just doesn't do it for me. You know, but on the other hand, you know, the really premium ice cream brands, they are amazing, but I can't stomach paying for them. There's just so much. I'm sorry, Aurelia, if you're actually fasting when we're talking about ice cream. Okay, and then the second question is, where would you go to buy it, right? So have all of these questions in the back of your mind. Someone said price. Let's take a look and I'll show you what I've come up with. What if, so we talked about this, what information would you need to make an informed decision? Price is definitely one. The other thing that I'd probably say, or someone said quality, but the other thing that I would say is how much ice cream, right? Like, because not all ice cream comes in the same tubs. Some of them come in massive 4-liter tubs. Some of them come in like little tiny tubs. Some of them aren't even in tubs. They're like stick ice cream. So maybe weight or the amount, volume of ice cream, maybe you have to consider that as well. This is what I came up with, right? If you went to the store, and I'm sorry for shameless brand recognition here, but I went into the online stores and I looked up ice cream and I found Ben & Jerry's at Coles and at Farmer Jack's. Now, at Coles, it was $12. At Farmer Jack's, it's $12.99. This is the exact same tub of ice cream, 458 mils, Ben & Jerry's chocolate chip cookie dough. Hands up and tell me, or in the chat, which one would you buy and why? Aurelia said she'd go buy the expensive one, so she'd go to the Farmer Jack's. Of course, Coles, right? It's cheaper. Now, this is a no-brainer because everything's the same. It's the same type of ice cream. It's the same amount of ice cream. You just go for the cheapest one, right? Doesn't matter. Go Coles. I just snorted. This one's a little bit trickier, right? If you went to the store and you saw rainbow ice cream and you saw original vanilla ice cream, but the rainbow ice cream was 2 liters, the vanilla ice cream was 4 liters, and you've got the 2 different prices, right? Which one would you choose? Now, let me give you a fun fact. Rainbow ice cream is exactly the same as vanilla ice cream, right? There is no difference in the flavor except for color, right? Color is the only difference. So don't be fooled. They're exactly the same. If you don't believe me, go check it out, right? Go get some rainbow ice cream. Go get some vanilla ice cream. They taste exactly the same. All right. Now, which one would you choose and why? Go. Rainbow ice cream or vanilla ice cream? Tell me. All right. Someone's got it there. Alina said you can buy two 2-liter ice creams and it's exactly the same as 4 liters, but it's cheaper because double $4.75. You know, it's $9.50, not $10. So this one's really quite easy as well. It doesn't really, there's not really a hard decision to make here because the amounts, we can quickly compare them and making them exactly the same amounts. I can go from 2 liters to 4 liters very easily. I can go from 4 liters to 2 liters very easily. So I could halve the vanilla ice cream, halve that price, and then compare the price. Right? So what I want to drive home here is in order to compare something, that you have to make sure that you're comparing apples with apples. You have to compare the same amounts so that you can make a comparison on the price. Now, and it was very helpful that rainbow and vanilla are pretty much the same anyway. So that also made it very, very easy. So yeah, definitely go with 2 tubs of the rainbow ice cream. Easy. Someone says, no, I'm wrong. Why am I wrong? Oh, go to Woolies, it'll be cheaper. I don't know what you're saying I'm wrong about. Anyway, this one's a little bit harder, right? I've never heard of these ice cream. Who's heard of FroPro? What is this? Sugar-free ice cream. I don't even know what that would taste like. I don't know if it'll be any good. I'm not gonna trash talk them because I've never tried it. But hey, anyway, 520 mils. By the way, 520 mils, $10. We just had 4 liters for $10. What? Right? That's how crazy expensive this thing is. And we've got Streets Magnum Lux Salted Caramel for $9. Which one would you buy and why? Right? And let's say that our biggest concern is we want best value for money, right? We want price to be our biggest concern. So someone tell me which one you would buy and why. Someone said salted caramel. Sure, just because it's tasty. Yeah, I guess chocolate is a bit bland. It's not as exciting as Lux salted caramel. That's marketing for you. Which one is the best value for money? Anyone? Someone says the $9. You're telling me, but why? See you later, Martin. The whole thing about maths is being able to say to be able to justify your decisions using math, right? Using numbers. Someone tell me why. Why is Magnum the better one? Is it just because it's $9 and the other one's $10 and it's cheaper? Is it because the Magnum one just looks better? It's got gold and it looks fancy, right? Let's actually do some maths here. You ready? Now, I'm going to annotate here. Give me a second. What we want to do is we want to make a comparison, but we want to compare the rate. What I mean by rate, I mean we want to compare how much it would cost per unit weight, and we call this a unit rate. Now, at the moment, the units that the volume is measured in is both in mils, but they're not the same amount of mils. So what we want to do is we want to take this back down to per mil, how much does each bucket of ice cream cost, right? So what I want to do is I'm going to do the top one here. I'm going to do the $10. So let me tell you how to do it. You take the price and you divide it by the volume, right? Now, in this particular case, right, the top one, I'm going to take my $10 and I'm going to divide it by 520. Why? Because that will give me, look at the rate that I've written on the left. It will give you the rate in how much it will cost in dollars per unit of volume, right? So it'll tell me dollars per milliliter. And if I have both of my products here in dollars per milliliter, because they're all both in the same unit rate, I can very easily make a comparison. I can say, okay, whichever one's more is more expensive, whichever one's less is cheaper. So I'm going to use my calculator here, and I'm going to say, okay, sorry, the screen. Let me move my calculator over. I'm going to go 10 divided by 520, and that gives me 0.019. Now, let me just write this down again. So this is 0.019. Now, what does this mean? This is $0.019 per milliliter. Okay, so that's really saying it's 1.9 cents per milliliter. That's just how much it costs for every mil that you want of this ice cream, right? That's the rate that it costs. I'm going to do the same thing for the bottom one, right? I'm going to find out what does the Streets Magnum Lux Salted Caramel Tub cost per milliliter, so that I can compare them. So let me have a look. This is 440 mil for $9. Now, let me have a look here. Let me annotate. So I'm going to go again. I'm going to put the money on top. Now, remember, if people are spamming, Yaz is just going to turn off the chat. And so we've got $9 divided by, what was it, 400 and something, 440. And that's going to give me, oh, no, I don't want to use I need my thing here. Oh. So 9 divided by 440. What is this? 0.020. So where's my little mouse? Okay, so this is $0.02 per mil. Okay. So if I were to be strictly mathematical about this, someone said, how did I figure that out and how did I divide it? I literally went into my calculator and I did 9 divided by 440, right? In terms of how do I figure it out? Remember, I'm changing these into rates by taking the price and dividing it by volume. And so now I've got these two rates here. I've got the top one being 1.9 cents per mil and the bottom one being 2 cents per mil. So mathematically speaking, the FroPro is actually marginally cheaper. They're pretty much the same. But if you wanted to say which one was cheaper, the FroPro just by a little bit. But again, then you got to think, do you actually want 500 mil? Do you only want 440 mil? Who knows? Do you want to spend the extra dollar? So all of these other things start coming into play. But if you wanted to do it purely mathematically, this is one way to do it. Now, what would happen if you, instead of going price divided by volume, what would happen if you did it the other way around? Okay, so let's talk about what would happen if I did the volume divided by the price. Okay, what that would do is that would give me a rate, again, a unit rate of the amount of ice cream that you'd get per dollar that you spend. So you can do it this way, but you've got to interpret the rate slightly differently because it's something slightly different. So let me show you what I mean, right? Let's say I flip this around. I did 520 divided by 10, and that would give me 52. 52 what? Mils per dollar, right? So that's telling me for every dollar that I spend, I get 52 mils of FroPro. Let's do the same thing for the salted caramel one. So I could do 440 divided by 9. Let me do that on my calculator. Can everyone see my calculator, by the way? Let me just unshare and share my screen. Sorry, I thought you could see my calculator. Oh, where did all my working go? Let me try again. All right, I've just pulled it. Okay, I'm gonna have to do that again in a second. So what was this? This was 520 divided by 10, which was 52 mils per dollar. Oh, I don't want this. Get out of here. Okay, 52 mils per dollar. And then the next one was 440 divided by 9. And let's do that. What's this? Oh, goodness gracious me. 440 out of 9. And I've got, what's this number? 48.8 recurring. So I'm just going to round that out. So this is 48.89 mils per dollar. Okay. So the question that I want to ask now is, which one would you choose and why? Right? Now, before we chose the lowest number, if we were to choose the lowest number here, we'd be going with the Magnum. Why isn't that correct? Why should I still choose the FroPro? Someone tell me in the chat. Anyone? Well, it's in the rate, right? Let's have a look at the rate. It's got, what we've got here is we've got mils per dollar. So the bigger the number, the more volume of ice cream I'm getting per dollar that I spend, right? So in this particular case, because we flipped the way that we did the rate, and we've got volume on top, we want more volume per dollar. Whereas if we had the dollars on the top, we want less dollars per volume that we purchase, right? So you just got to interpret the rate that you do. Now, different rates are going to be more useful than others. So in this case, it didn't really matter because we can interpret both ways, but in other circumstances, it's going to be important the way that you choose to, which quantity you choose to divide one by the other. All right, so that was my quick lesson on rates in the marketplace. And now you know how to find the best value of something. Let me just clear my screen. And what we're going to do is we're going to jump into Mathspace now, and we're going to do some questions. And while we do these questions, we are going to be, learning about ratios and rates as well, okay? So let me just double check the time. Let me jump out of this, actually. It's not playtime yet. It is Mathspace time. How much time we got left? We got about 30 minutes. All right, so, okay, so rates is a comparison of two quantities, and it basically allows you to bring it down into unit rates, which is easy for comparison. The other way to compare two quantities is what we call a ratio. And a ratio literally is one thing compared to another thing. And so here you'll see it says, give your answer in the form A to B. These A and B are just the two quantities. So this is asking, write a ratio for the number of circles to squares. So what I've got to do here is I've got to make sure that circles is the first number and squares is the second number. So someone's already did it, and they said, okay, I've got to count the number of circles. There are 2, 4, 6, 8 circles in here. So my ratio here of comparing circles to squares is going to be 8. Now the column in the middle just means it tells you mathematically that this is a ratio of comparing two quantities. And then I've got to count the squares. So the squares here, there are 9 of them. So the ratio is 8 is to 9, okay? Boom. All right. Let's do the next one. Write 8,000 meters to 3 kilometers as a ratio. Now, whenever we do ratios and we're comparing two quantities, if we're comparing two quantities that are the same type, so in this case, meters and kilometers are the same type, meaning that they're both measuring length, we want to compare them in the same unit. Now, notice that meters and kilometers are different units of length, right? Meters is smaller than kilometers, right? 1,000 kilometers fits into a meter. So, sorry, I totally said that the wrong way. 1,000 meters fits into a kilometer. So what we have to do is we have to convert both of these quantities into the same unit first. And by the way, just to let you know, all of the stuff that we're doing today, again, you're going to need to know it for the game at the end. So tune in, right? 8,000. So what I'm going to do is I'm going to take the 8,000 meters, and I can either convert meters to kilometers or kilometers to meters. Doesn't really matter. I'm going to convert kilometers to meters. I'm going to go the long way on purpose. You could convert meters to kilometers straight. I'm going to go the long way for a reason, right? So 8,000 is going to stay the same. I'm not changing the meters. I am going to change the kilometers though. So 3 kilometers in meters, well, 1,000 meters fits into a kilometer. So that means 3 kilometers is 3,000 meters. I've now got the ratio of 8,000 meters to 3,000 meters. And just like, notice that Mathspace has told me I'm not there yet. I haven't got my final answer because I need to simplify my ratio. Now, simplifying ratios is exactly the same as simplifying fractions. Someone tell me, what are you looking for when you're simplifying a fraction? You're trying to find something so you can simplify it. What is that thing? Someone says take away as many zeros. Now, technically you're right, you can just take away zeros, but that's not what I want you to think, right? Because that's too simple a way of thinking about it, and you're not always going to get zeros in your numbers, right? So I don't want you to think just take away the zeros. I want you to think something different. Alicia's got it. Close. You're super close. It's common something, but it's not common denominator, right? What is it? Highest common, Arian's got it, factor, right? You want the highest common factor. What number goes into 8,000 and 3,000 that is the biggest? Now, if you don't know the biggest, that's okay. You just do it one at a time. You just find a factor that goes into both, and you divide both of them by that number. Now, someone said you can just take away zeros. And the reason why you can take away zeros here is because 10 fits into both. And every time you divide by 10, you lose a 0. So for example, I can divide both sides by 10 and get 800 and 300, and that will still work, right? But I can go bigger. I don't have to go by 10 each time. I can go by 100. I could go by 1,000. I could go by 5. I could go by 2. But it doesn't really matter what you go by. As long as you keep dividing until you can't divide anymore, you'll get to the final answer. Or if you want to do it all in one step, you find the biggest one. Now, the biggest one in 8,000 and 3,000 is 1,000. 1,000 goes into both of them. So if I divide both of them by 1,000, I get 8 is to 3. And I'm done. Okay. Now, notice very clearly that I couldn't do 3 to 8, right? Because the way that the ratio is set up is that 8,000's first and the 3 kilometers is second. So I can't just switch them around. The order matters. The place in which the numbers go matters. All right, let's keep going. All right, 7 centuries to 859 years is a ratio. I'm not going to say anything. I'm going to give you guys 30 seconds. Have a go. Write this as a ratio, 7 centuries to 859 years. And do working if you need to. Don't think you have to go straight to the right to the straight answer. I can't. Most of the time, I can't go to the straight answer straight away. The right answer straight away. Please do working out. A couple of people have got it in here already. All right, you're comparing years to years. So you've gone 700 to 859. All right, let's do it. Let's see what this says. Boom, easy. Okay. Complete the equivalent. All right, so ratios are like fractions. And just like you can have equivalent fractions where I can say, let me just get my annotation up. I can say, you know, a half is the same as 2 quarters. Oops, that didn't work out properly. Which is the same as 3/6, right? The way that I get all of these fractions is exactly the same as how I get equivalent ratios. So to go from a half to 2 quarters, remember, all I do is I multiply the top and the bottom by 2. And I get 1 times 2 is 2, 2 times 2 is 4. So 2/4 is the same as a half. When I have ratios, it's exactly the same, right? I can go, okay, how do I go from 9 to 18? Whatever I'm multiplying by, I just got to multiply the left side by the right side by the same amount. So because I can multiply the left side by 2, I can multiply the right side by 2, and I'll end up with an equivalent ratio. So 9/5 is the same as 18/10. So if I want to go to 9/5 is the same as 27 is to something else, I've just got to figure out what am I multiplying the left side by to get to, and then whatever I'm multiplying the left side by, I do the same to the right side. So let me clear all of this. Give me a second. So I'll go, okay, 9 times something gives me 27. What 9 times what? Let's do our 9 times table. 9, 18, 27. So it's 3. Which means that to do the right side of the ratio, I've just got to do the same thing. I've got to multiply this side by 3. 5 3s are 15. Okay, so that's going to be 15. The next one, 45, 9 is to 5 is the same as 45 is to something. Can someone tell me what that second number is going to be? Actually, don't tell me what the second number is. Tell me what you're going to multiply by on the left side and the right side first, right? Because that's the important thing, right? Someone's got it. It's 5. 9 5s are 45. So I'm going to do the same to the right side. 5 5s are 25. Okay. So that right one's going to be 25. Last one. What do I multiply by to find out what the left number will be? So I can't use the 9 times something will give me the number I need to multiply. I'm going to use the other side. 5 times something is going to give you 50. What am I going to multiply by? 10. So I'm going to do the same to the left side, which means the left side, 9 times 10 is going to be 90. All right, so I'm going to clear all this. I'm going to put our answers in. Let's see if we are there. So we've got 9 times 3 is 27. So 5 times 3 is 15. 9 times 9, what was it? 9 times 5 is 45. So 5 5s are 25. And then this one here is 90. Boom. Oh, it's taking a while. It's thinking. All right. If there are 180 dogs, how many cats are there expected to be? Okay. So what we're doing now is something slightly different. The first part was we were creating equivalent ratios. In this second part, we're talking about splitting a number up into the ratio 9:5. Now, this is actually a pretty lengthy process, right? And we can do it because we did the table before. This actually makes it really easy. But I'm going to show you the short way and the long way, right? The short way is this: I can see that 180 dogs. If I can see something that splits up, I don't think I can do it the short way. If I can see something that splits up, for every 18 dogs here, I can have 10 cats. I don't know if this is going to work. I'm going to do this the long way first and see if it works in the short way, because double 90 and 50. Oh, yeah, you got it. Double 90 and 50. You're way smarter than me. Double 90 and 50, you got it, done, right? And this works really well because obviously 180 is a multiple of 9, right? So we can definitely do it this way. So let me just show you what this person said. So I can do this. I can go 9:5 and do exactly the same thing we just did and say, on the dog side, there are 180. And then I've just got to figure out, what do I multiply by? What do I multiply by? And it's exactly the same question as we did before, right? So 9 times 2 is 18. So 9 times 20 is 180. 5 times 20, just got to figure out what that is. That's 100, right? So, sorry, I think I pressed the wrong one before. So let me get rid of this one. So it's going to be 100. That is super smart, whoever came up with that, right? Which of the following is fully simplified ratio of 180 to 100? Well, that's the same as 9:5, right? But I want to get to one where you can't just do that, right? So, because I want to teach you the long way. So if you can just multiply it out, just like we did before with the equivalent ratios, go and do that. My head was at a more difficult place, but the simplest solution wins. Simplify the ratio. Let's just do this one. How do you simplify that ratio? 15 is to 24, please. Can someone tell me, what can you find that is a common factor in both the left side and the right side? And then what's the final answer going to be? Okay, divide both sides by 3. Yep, excellent. So divide the left side by 3, we get 5. Divide the right side by 3, we get 8. Oh, did I just do that wrong? What am I dividing by? Divided by 3. I'll put 4 in. What did I just do? Oh, should that be 5? Sorry, I'm not thinking. Duh. That was silly. All right. Write 450 to 400 as a fully simplified ratio. Let's go. What do we divide by first? That's what I want you to think. Don't tell me the answer. Tell me, what do I divide by first? What number goes into both 450 and 400? And you can do it step by step if you want. If you wanted to do it divide by 10 first, all right, let's do that. 45 is to 40. Okay, done. Now, but we're not finished yet because we can keep going. So what goes into 45 and 40? Can't divide by 15 here. 15 doesn't go into 45. 5 goes into both. 5 goes into 45 9 times. 5 goes into 48 times. And we're done. Oh, sorry, someone said 15 from the original question. Yeah, you're right. I want to get to a hard question. All right, okay. This is hard for a different reason, but not what I want to do, but let's keep going anyway. Now, if you want to simplify fractions or decimals, right, what we want to do is we want to change these fractions or decimals into whole numbers and then simplify like we've been doing before. How do I change a fraction into a whole number? Well, the simplest way to do that is to multiply both sides or both fractions by a number that gets rid of the denominator. Now, in this particular case, it's easy because we can multiply both sides by 11. Let me show you why. If I multiply 8/11 by 11, now this is going to go back to our fraction work. Remember that when I multiply a fraction by a whole number, that whole number I can change into a fraction because any number is a fraction over 1. And now that I've got two fractions multiplying by each other, I can simplify and then just multiply. How do we multiply fractions? You just multiply the top, multiply the bottom. So if I want to, I'm gonna do that first, right? I'm gonna multiply first, then simplify second, and then I'm gonna show you how to simplify first. I can go 8 times 11 is 88. And then I can go 11 times 1 is 11. And 88 divided by 11 is just 8, right? So that's one way to multiply two fractions. But if I wanted to, I could actually just simplify first and get 8 straight away. If I'm looking for any common factors in the tops, in the numerators of my fractions, and then look with any sorry, I just said the wrong words. If I look for any common factors in the top that have any common factors with the bottom, I can simplify straight away. So I can see 11 has a common factor with 11 on the bottom. 11 goes into both those numbers. So I can say, okay, I'm going to divide the top by 11, which gives me 1. I'm going to divide the 11 on the bottom by 11, which gives me 1. And that gives me 8 times 1, which is 8. And then on the bottom, 1 times 1, which is just 1, which gives me 8, right? I can just get my 8 straight away. So notice that when I multiply 8 elevenths by 11, I'm just going to get 8. If I multiply 9 elevenths by 11, I'm just going to get 9. And so what I've done there is I've now put them both into whole numbers, and then I do what I normally do. So let me put this in here. 8 is to 9. Right, that's the first step. Get rid of the denominator. It just so happens that 8 is to 9 is the simplest fraction I'm going to get. But if I could, I'd then simplify the 8 is to 9, right, and go further. So let's try it again. So this is different. 4/5 is to 6 elevenths. Now, I'm not going to be able to just multiply both sides by 5 here. And I'm not going to be able to multiply both sides by 11. Because if I do that, I'm not going to get a whole number. I'm not going to get rid of the denominators to make them whole numbers. Let me show you what I mean. If I multiply 4/5 by 5, that will turn it into a whole number, right? It'll go 4, the 5 and the 5 will cancel, giving me just 4. But if I do 6 elevenths times 5, I am not going to be able to get rid of that denominator on the bottom. It'll give me 30 over 11. There's no common factor in 5 and 11 to cancel, right? I can't do anything with that. So what we want to do is, someone said it, we want to find a common denominator, the lowest common multiple, right, of 5 and 11, and multiply by that. Now, lowest common multiples, what does that mean? Let me just quickly erase and show you. Remember, a multiple is literally your times tables. So let's do the multiples of 5, right? Your multiples of, wait, let me draw. The multiples of 5 are 5, 10, 15, 20, right? All the way up. Continue, like whatever. It goes on forever and ever. They're all your multiples of 5, your 5 times table. Your multiples of 11 are 11, 22, 33, 44, right? 55, and it just goes on and on and on. Now, what I want to find is, what is the lowest common multiple of 5 and 11? Does anyone know what the answer to this is? It's actually, in this particular case, 55. Now, in this one here, that is just 11 times 5. But the lowest common multiple isn't always just the multiplication of those two numbers, right? Sometimes it is, sometimes it isn't. So what I strongly suggest that you do is that you do this list and you look for the lowest common multiple. Now, if you want to, you can find a common multiple just by multiplying the two. It might not necessarily be the lowest, that's all. So you can just multiply the two and get a common multiple. It just might not always be the smallest. All right, so in this particular case, 55 is our lowest common multiple. I'm going to multiply both sides by 55 and watch what happens. I go 4/5 times 55, okay? And I go, okay, I'm going to simplify first before I multiply. 4 times 55, yes, I can do it, but it's a bit big, right? I'd rather work with smaller numbers. So is there any common factors in the 4 and 5? No, nothing common to cancel out there. Is there anything common in the 55 and the 5? Definitely. There's a common factor of 5. So I'm going to divide 55 by 5, which gives me 11. I'm going to divide the 5 by 5, which gives me 1. And what that gives me is, when I finish this out, 4 times 11, 4 times 11 is 44. And then on the bottom, I'm just going to get 1. So I actually just, for the 4/5, when I do times that by 55, I end up with 44. I'm going to do the same for 6/11 times 55. Okay. Now here, I can simplify by what's common in the 55 and the 11. Well, 11 is common. So I'm going to divide the 55 by 11, giving me 5. I'm going to divide the 11 by 11, which gives me 1. And then I'm going to multiply. So 6 5s are 30. And 1 times 1 is 1. So on the left, when I multiply both sides by 55, on the left I get 44, on the right I get 30. So let me clear all this. So I'm going to get, what was my first number? 44. I'm going to get 44 is to 30. Now, remember, this has told me that I'm not quite there yet. Why? Because I can simplify. Thank you, Sarah. There's a number that's common in 44 and 30, and that number is 2. So halving 44, I get 22. Halving 30, I get 15. And voila, I'm done. Now, some of you may also notice that you could actually use cross multiplication here to do this a little bit quickly. I showed you the long drawn out way because if you get stuck, you can always go back to what are those fundamental processes that you have to do to get the answer. But there's another shorter way to do this, which is what is it? Okay. So what I can do is I can just cross multiply here, right? If I just multiply 4 by 11 and 5 by 6, I'll end up with my 44 by 30. And then I can keep going from there. So that's another way that you can do it. But the reason why this works is is from what I showed you before, right? By multiplying both sides by the common lowest common multiple, and then simplifying from there. All right. Now, how much time do we have left? I have so much more content to go. We've got about 10 minutes left. What we might do is we might skip the rest of this. There's so much I haven't shown you. There's so much I haven't taught you, but let's play our game and see how we go, okay? I strongly suggest that if you go into the game next and you're like, oh my goodness, I don't know how to do any of this stuff, in your own time, go back to the textbook. If you have Mathspace, go back to the textbook, go to Year 7, ratios, rates and money, and work through some of these questions. Look at the lesson. The lesson will tell you how to do everything, and there are videos about how to do stuff and solutions as well. Come back here, learn how to do it so that you know how to do it for later, okay? Now remember that you are in charge of your own education. Your school is not in charge of it. Your parents aren't in charge of it. So if you want to learn faster than what your parents and your school is teaching you, go ahead and do it. Do it because you want to do it. Don't do it because you don't do it. Don't just stop because your school's not up to there yet. Don't just stop because someone hasn't taught it to you. Go away and learn it yourself, right? Now remember, if you don't have Mathspace, you can go onto the internet and there are plenty of other places that will teach you this as well. Go and seek knowledge by yourself, right? Okay, let's go into our game. Oh, I didn't set this up, so let's quickly do it. We're going to go to Gimkit again. Oh man, this was fun. Yaz, feel free to play. I am going to crush some people today. Let me just quickly log in. Now remember, you go to gimkit.com/play, and I'm just going to start up this game. All right, so we're going to play. Instead of going for time this time, we're going to go for a race. And rather than going for $1 million, I don't know how long $1 million is going to take, but let's just go to something modest, right? Let's go to $10,000. I don't remember how long it took us to get that kind of money, so we'll see how we go. Yeah, you can have all the power-ups. I don't know how teams work, so that's why I don't want to try it just yet. And we don't have that many people on the call, so we're just going to go solo for now. All right, so go to gimkit.com/play and go to 49895 as the game code. I'm just going to split my screen right now. Oh. All right. Hey, what happened? All right. We've got 10 people in. I think there are about 15 people here today. So if you don't know what we're doing, jump into gimkit.com/play, where I am right now. Type in the game code 49895 and my name. Type in your name. Okay, we've got 12 people in here. Last 3 people are going to come in. I'll wait another 10 seconds for you. Otherwise, if you can join late anyway. You're just going to be at a disadvantage. All right, I'm going to start in 3, 2, and 1. Let's go. Hurry up, Oliver. Come on. All right, too late, Oliver. I waited extra time. You can just join in late. All right, let's go. All right. Guys, go to the shop first. Measuring fuel, dollars per liter. Yeah. Oh, I don't want to go to the shop yet. There are 20 monkeys and 17 birds. What is the ratio of monkeys to birds? So we'll have the ratio 50 to 200 to its simplest form. 50 goes in both, 1:4. Oh, what can I buy? Yeah. 15 minutes to an hour. 15 is 1:4. What is the ratio of weekdays to weekends? 5 to 2. Ratio of pears to apples to oranges. 3. Oh, we didn't do 5 pears, 3 apples, 2 oranges. Select the simplest ratio of pairs to the total. There are 10 things in total, 5 pairs, so it's 5 to 10, which is 1 to 2. Oh, I forgot you can attack people. Iron Beast, what are you doing? I'm not even the top. Get Kabir. Simple ratio of 0.5 to 2. Okay, I multiply both sides by 1, so it's 1:4. 20 to 16. Both goes to 4 for 5 is to 4. Shop. I need more stuff. I need more streak bonus. Select the ratio of oranges to the total number of fruit. There are 2 oranges. Total fruit is 10. 2 to 10, 1 to 5. A man walks 45 kilometers over 3 days. At what rate, round to the nearest meter, is the man walking? 15 kilometers per day. Oh, yes, you're killing it. 5 is to 3 is 30 is to x. So 5 times 6 is 30. So 3 times 6 is 18. What? 7 cars and 2 trucks equivalent to what ratio? 7, 14, 21, 28. Not that one. 7, 14, 21, not that one. 7, 14, no. Must be this one. That's ridiculous. Yaz is killing it. Okay. 72 is, oh, blur. Wow. 17 is to 18 equals 18 is to x. What am I dividing by? Holy moly. Divide by, not by 9. Divide by I thought, geez. I'm assuming I'm going to divide that by Holy moly. Did I do this wrong? My brain just froze there. I had no idea what I was doing. Oh, goodness. A pet store has 8 dogs. What does 8 to 23 compare? 8 to 23. What's 8? Dogs. Dogs to all animals. Oh my goodness, got really slow. 100 centimeters in a meter, 1,000 to 500.
Don't use the thing on me.
It wasn't me. What is the ratio of A's to B's in banana? A's to B's, 3 to 1. I need to buy stuff. What can I buy? Come on, give me something. Yeah. What would be an appropriate rate to measure the object? Oh, goodness. This is actually quite cool. Like people who are changing for top place are changing all the time. Get Yaz, please. Get Yaz. That'd be an appropriate rate to measure the object. Blue hats to red hats. 3. Oh, I can't read this to put an answer in. Where's 3 to 2? Which one's 3 to 2? I don't want to lose my streak. Blue hats to red hats. Oh, 2 to 3. Here we go. There were 9 dogs and 15 cats. Write the ratio of dogs to cats. 9 to 15. 3 to 5. Ratio to all. Surely I can buy something. What's the next one? 15,000. Wow. 10,000. I'm going to meet the goal to get to 10,000. So that means it just... People bought 20 boxes of crayons for $65. What would be the cost? You may need a calculator. Yeah, this one you definitely need a calculator. 20 boxes for 65. 65 divided by 20. Oh, actually, no, you could do it by hand. 325. What? In a room of 12 people, 40 people, there are 18 adults, the rest are children. Right, simplest ratio of children to the total number of people. 22. Simplest. 22 is to 40. 11 is to 20. Gwen uses 4 tomatoes to make soup for 3 guests. How many tomatoes will she require to make a soup for 15 guests? Okay. Times that by 5, times that by 5, so I need 20. Simplify a half to 2/3, times both sides by 6. So 3 is to 4. Simplify 1.5 to 3/4. 1.5. 1.5 is the same as 3 on 2. Times both sides by 4. 3 on 2. 6 is to 3. 2 is to 1.
Someone iced me.
Oh, I'm catching up. Oh yeah, I'm in the lead. Honey is sold in 600-gram containers for 12 each. At what rate is the honey being sold per liter? Oh, geez. So I need to take it back down to 1 gram, put it up to 1,000. So it's 12 divided by 600 times it by 1,000. And that's 20. So the ratio 81 to 45.
Thanks for the gift.
9. 6 to 5. There are 3 apples, 2 oranges, and 5 pears in a fruit bowl. So let's simplest ratio of apples to pears. 3 to 5. In a room of people, 40 people, there are 18 adults and the rest are children. Write the simplest ratio of adults. I'm going to stop talking. I'm going to guess this one. I'm going to guess sprinkles. Oh no, it's skinny. Which ratio is equivalent to 50? Crabs to clams. 3 to 2. Can't read. Oh. Crabs to clams. 3 to 2. This is ratio. Adults to children. 18 to 22. Oh, I think I'm going to win. One more question. Yes. All right. Yeah. Woo! I guess I guess it's not. I do have a bit of an advantage since I created most of these questions. I won't play the next one. But there were lots of questions in which I stole from other people. So yeah, I took some time. I had to take some time on some of those ones. All right. Well done. Thanks for playing. I am going to get rid of this. All right. So how much time we got? We're probably out of time. So we've gone 5 minutes over. I'm going to give you the last little bit, which is the puzzle, and then we'll call it a day. If you need to go, see you later. Thanks for joining us. Otherwise, stick around, and would love for you guys to be sending me solutions to these puzzles. Right? In the feedback, can you let us, or if there is a place, can you let me know whether these puzzles are something you're interested in? Because I'm doing them, I'm not actually getting very many responses, but I think these are really cool. But if we don't want to do them, maybe we can use that time for something else. So this is the puzzle for this week. There is a staircase, and it has 12 steps on this staircase. Isabel decides to go down the staircase and can choose between going down one step at a time or 2 steps at a time. So here's the staircase. I drew it in paint by myself. Yes, that's how amazing I am. And so for one particular example, Isabel could go down the steps by doing 1 step, then 1 step again, then 2 steps. So basically 2 steps means that you just skip a step and you go to the second step. 2 steps again, 2 steps again, 1 step, 1 step, 1 step, 1 step, right? And then she gets down from the top to the bottom of the stairs. Now, the question is, how many different ways can Isabel go down the staircase by only taking 1 or 2 steps at a time? So like you could go 1 step the whole way. That's one way of doing it. A second way of doing it is the way that I just showed you here, right? How many different ways can you combine 1 steps and 2 steps to go down the stairs? Really is what the question is asking. Now, are there any questions about, are there any questions about this puzzle today? Okay. Now, remember that this presentation is going to be uploaded onto the Mathspace Academy website. If you want, take some screenshots of this particular slide. If you want me to go back to a previous slide, just let me know. Would definitely love to hear from you. Now, that's the end of our lesson. This recording, again, will be up on Mathspace Academy website. Give it a day or so. Please, if you can, pass on some feedback to me by doing the survey that gets emailed out to you at the end. We'll definitely love to hear your how you think this is going. If you've got any ideas about how to make it better, we'll definitely love that as well. Okay, so thank you so much. Thank you, Yasmin, for helping us out today. And thanks everyone else for coming. Have fun at school. Have fun learning this week. See you later, everyone. Have a good day. Bye.